Hello, everyone. I would like to first start by thanking the organizers for giving me the opportunity to still give this talk and contribute to this very interesting online meeting. So I will be talking about our project using VISIR to map the galactic center massive clusters and with a concentration on the case of the nuclear star cluster. So as a short reminder of what you have heard from Reiner's very nice review of the galactic center in the mid-infrared, the nuclear cluster is the closest and most resolved nuclear cluster accessible to us. Therefore, we can study it in great detail, which would allow us to study its stellar population, the interaction between its different constituents, and also the emission from the supermassive black hole situated at its heart, which is marked here by a cross, and as you know, its name, Sagittarius A star. So the nuclear cluster, the stars are surrounded by dusty and clumpy molecular emission that places itself in what is called the circumnuclear disk or ring, which you can see here is traced by the green emission. And this is connected to the center of the cluster via ionized gas and dust streamers that appear in a structure called the mini spiral, which is a three-armed structure that appear in projection as a spiral, and therefore it's called the mini spiral. So this is what you see here. It is displayed in blue, and what you see here is the northern arm of this mini spiral, the eastern arm, and the western arc would be in this direction. To concentrate only on the infrared and in particular the thermal infrared. So as you can see in this 3.8 micron image taken with NACO, is that we have an increased density of sources as you go closer to the center of the cluster, which is the position of the supermassive black hole marked by cross here. And you see a lot of bright and massive sources, bright and massive stars, and also heated dust. And this heated dust also manifests itself in filamentary structures that also trace part of the northern arm of the mini spiral, like in this case here, and also the eastern arm. Going to longer wavelength in the mid-infrared from ground-based telescopes, then also you can start to analyze the interaction between these massive bright sources with the surrounding interstellar medium. And in this particular case here, these sources seem to have produced bow shocks as a result of this interaction between the stellar wind of these massive stars and the material that is within the northern arm of the mini spiral. And one of the earlier datasets, actually the earliest dataset that was obtained with VISIR on the galactic center, taken in NNQ band, allowed classifying many of the compact sources that was found in this region. And this classification basically was done by combining the mid-infrared dataset with shorter wavelength data taken with ISAC and NACO, in order to look at the spectral energy distribution of these detected sources and classify them into hot, cool stars, bow shock sources, dusty concentrations, and also young stellar objects candidates, as the case here for these 5 stars, which are called the IRAS-5 complex. And of course, at the heart of this cluster is the position of Sagittarius A star, which what you have heard from Reiner's talk is that the emission from Sagittarius A star longward of 5 microns cannot be detected, and only upper limits exist so far. And this is due to the complicating presence of the diffuse emission and dust very close to the position of Sagittarius A star, which complicates finding a point source at this position. So to go to the dataset that we have obtained over the past few years, so we have obtained the dataset in 2 wavelengths in the N band, and the 2 filters, the PAH and the neon. And we've done this over 3 years, so in 2010, 16, and 18. And we targeted 6 regions in the galactic center, so the 3 massive clusters, and also regions nearby. We used the raster mode of VISIR, which allowed us to image and mosaic a larger field of view. And this I will show you now, the resulting mosaics, the initial mosaics that were resulting from the initial data reduction of the data sets. So this is the one for the central stellar cluster, the quintuplet cluster, where you can see the 5 stars that give it its name, the arches cluster, and the regions in the arched filaments. Now, by concentrating only on the case of the nuclear star cluster and considering we have many observations, we with the varying chopping and nodding parameters, we were able to combine the images into one large mosaic that has minimal background subtraction residuals. However, we still didn't do image restoration, which would be the next step in order to enhance the diffuse background emission detected at this region. So what you see here prominently in this two-color image, so combining the two wavelengths that we have, are the bright sources that you have seen already, the ones that have Bow-Shock emissions, and also the large dusty structure of the mini spiral, so the northern arm, the eastern arm, and also traced by the longer wavelength filter is the western arc. There are also sources detected outside this inner bright region, but however, due to the dynamic range of this image, it's hard to see in one go. But since we have now two different wavelengths and several data sets, then we are able to look at more information about these detected sources. So for instance, spectral index information. So by looking at the slope of lambda f lambda versus lambda, then you can determine spectral index of the sources that have a matching correspondence between the pH and the neon filter, and which you can see here on the right hand side, where the gray squares represent the detections in the 8.6 microns, while the colored circles represents the sources that have a detection as well in the longer wavelength, which then enabled us to determine the spectral index. Now, having only spectral indices based on two different wavelengths is not enough to classify these sources. Therefore, we are combining now the detections with shorter wavelength correspondences in order to better constrain the spectral index slope and classify these sources, whether we are looking at Bow-Shock sources, dusty sources, or even young stellar objects candidates, similar to what was done in Feynman, but now for a larger field of view. Also, since we have data sets obtained over several epochs, and in particular for the pH 8.6 microns, we have 6 epochs, then we can start looking at the flux density variations of these detected sources. And here I show you a couple of examples of some of the sources that either mostly are constant within the error bars or the uncertainties of the flux densities, or that they show slight variations, which we are investigating at the moment. Besides looking at the compact sources, also you can start analyzing the diffuse emission. And as you may have remembered from the position of Sagittarius A star, the presence of the extended dusty structure, we found that a filament very close to the position of Sagittarius A star that has a correspondence also in the bracket gamma emission, which allowed measuring the proper motion and analyzing it in more detail. And it was found that it is moving westward away from Sagittarius A star, and it is believed to be part of the turbulent mini spiral structure that is behind Sagittarius A star. Moreover, you can look at the Bow-Shock sources, and we looked, for instance, on the case of Iris 8, so the very bright Bow-Shock source at the north of the nuclear cluster, where the neon image allowed studying or placing limits on it as a 3D position in relation to the northern arm of the mini spiral. As well, we are looking at another candidate Bow-Shock source that is located further away to the southwest of the cluster. So I leave you here with the summary. And so the Galactic Center is a very interesting region to look at. The ground-based telescopes remain with an advantage that they give us the high resolution despite the complications in the background subtraction techniques. However, we are able to look at these regions and produce a catalog of faint compact sources, which then we classify as these candidates, YSOs or Bow-Shocks. And of this data set also was used to help in preparing the GTO time of Miri, and also later would be with Metis. So thank you very much, and looking forward to your questions.